Okay, Megan, today I'm going to show you the linear systems of equations. And when doing this, I'm going to show you right now the substitution part. When you have a system, a linear equation, and a system of them, a system means like there's more than one to solve for, then that is a system. And so it can be solved two ways. It can be solved by substitution or elimination. And I'm going to focus on substitution. Right now. I'm going to give you 3 examples, and including this example here just to kind of make you understand. But at first I'm going to start with something a little easier than this one because this one does turn into fractions. I'm going to start with something a little bit more simple with substitution. So with that being said, I'm going to show you how to take our system of linear equations, and I'm going to teach you how to substitute to find x and y. Remember, when you're doing linear equations, most of the time the goal is to solve for either x or y or both. And this is a system, so we're trying to solve for both. We want to solve for both x and y. So I'm going to take 4x plus y equals 5 and 2x minus 3y equals 13. And this is my system. This is what we're going to be solving today in this video, and I'm going to solve 2 other ones with you as well. So we're going to start with step 1. Now, step 1, you want to pick which of these linear equations is going to be the easiest to get the either x or y factor on one side. You want just to be able to solve for one at this point. And of course, if you look at these, the easiest one is this one because y is already by itself. Now you have to remember that when you see a y by itself, it's not necessarily by itself. Remember, there is an invisible 1 there. You have to always pretend that there is a 1 there. And you can't forget that because later you may have to subtract the -1 or divide a -1 or something. You would have to do something with that 1. And sometimes that can change the answer later. So remember that there's always a 1 there. Like this has a 4 in front of the x, so this is 4 x's. And then so this is a positive 1y. So you got to pretend there's a 1 there. So I'm going to take this equation, I'm going to take this linear equation out of this system, and I'm going to solve for y at this point. And so I'm going to take 4x plus y equals 5. And I'm going to, because this is positive x, I'm going to do -4x on both sides, -4x on both sides, which gives me still that positive y. But remember, a positive and negative, they cancel each other out, so we don't need this section anymore. The positive and the negative, they cancel each other out. It's basically saying positive 4x, -4x, and you are taking them out of the equation. They are now finished. You don't need them anymore. So then you go over here and you put y, because y is still left, equals 5 -4x. We don't want to say minus. I'm trying to get that word out of my vocabulary right now. We don't want to say minus. It's -4x. So 5 -4x. And so now we have y equals 5 -4x. And what we're going to do with this is, because now we know that y is this, we're going to substitute the y here for 5 -4x, because then that would make it where we can only solve for x. So now we're going to solve for x. So step 2 is, step 1 was taking and simplifying this down to y into an equation that we can work with and substitute in for our other equation. And you'll see how this comes into play here in a minute, because we're going to need this again later also. But step 2 is to take 2x at -3y equals 13 and substitute the y for what we have up here. So I'm going to rewrite that 2x -3 multiply 5 -4x equals 13. And so now we have a new linear equation to solve for, but with no y's. See how there's no y's? Now we're only focused on an x, and we can finally find out what x actually, is actually going to equal. So in order to do that, we need to take this -3 and multiply it by 5. But we know 2x stays the same, but the -3 times the +5 is -15. And then the -3 multiplied by the -4x becomes a +12x. And then it still equals 13. Now let me talk to you about this negative and this positive. Like if you were to do addition, when you add, if you do even plus even, you get even, okay? And then when you do even, excuse me, and sorry for my messy handwriting, in even plus an odd, you still get an odd. And when you do an odd plus odd, you get even. Well, this is kind of like when you talk about negatives and positives. So if you have a positive and a positive, it stays a positive. When you have a positive and a negative, it still is a negative. And when you have a negative and a negative, it becomes a positive. So it all builds on each other. That's why we start at a very young age with addition, and we move on to subtraction, and then we move on to multiplication and division. And you have to remember that all numbers all whole numbers can be numbers that are negative. So like -2, -1, and 0, and then +1, +2. All of these numbers, no matter if they're negative or if they're positive, including 0, are all whole numbers. You want to make sure that you remember that, because anything in between them are your fractions, your percentages, and your decimals. And that's where the math gets just a little harder for most people. So I wanted you to kind of have an understanding of that. So we're going to move back down here now that you might have more of an understanding of why positive still is positive, and positive and negative is still negative, and negative and negative is going to change to a positive. It kind of gives you maybe a little bit of information on why that might be the case. So in step 1, we took the easiest equation to solve for y. And then we took the easy and we simplified it. We just wanted to solve for y. And it was the simplest one, because we already see that there's just a positive 1y right there. And that just made it easy to figure out. And so then we're taking that equation that we came up with and we're substituting it into our second system. And our second system, and that's what we're working on right here. But if you see here, we have a +2x and a +12x. Well, +2x and a +12x is a +14x. Okay? And then you have right here a negative 15. So a -15. And that's equal to 13. So now again, we took it and we made it into 1x. We need 1x because we're only solving for the x. We want to know what x is actually equaling when we do the system. Okay, so then now to still figure that out, we want to take this -15 and we want to include it over here. So we're going to say -15. So instead of doing -15 in order to cancel them out, we have to do +15, +15. Now these two are canceled out. They are no longer needed. So now our new part of the system that we're working through is 14x because it's still there, and then 28 equals 28. So now we want to get to that x, and so this is multiplication. Of course, the opposite of multiplication is division, and every time you see a fraction, it is division. And you have to think of this line as division. Even in fractions, you have to think of it as division. So we have 14x, positive 14x, and we're going to divide both sides by 14x. 14. Let's take the x out. 14. And so then that gives us, these are canceled, and so that leaves x equals 2. So now we know for sure we've already solved now for x. X is for sure 2. This is the solution to x. And the solution to this linear system, x equals 2. So if we were to put a 2 up here in your system where x is, then it should work out. Now we got to figure out what y is. And remember, we only found y and it still had an x in it. So we want to put that y by itself. So that's where step 3 comes in. Now we want to take this equation that we use and we want to do step 3. Okay, and so when we do step 3, we take the equation that we came up with up here, and now we're going to solve for y. So it's y equals, and it's up here, 5 minus 4x. But instead of x, okay, remember we know now x is 2, so we're going to rewrite that again. Y equals 5 negative 4 multiplied by 2. So y now equals, well, negative 4 times positive 2 is 5 negative 8, which if you do positive 5 negative 8, y will equal 3. Negative 3, because you still have negative 3 left over. And so this is the solution to y, is a negative 3, and the solution to x. And so now we have solved this system of linear equations by using substitution. Remember, this is substitution. There's still a way to take the same equation and do elimination, which I will show you in the next video. Right now I'm going to show you 3 problems using substitution. Okay, and so I want to focus only on substitution at this point, but we'll take that same equation in another video, or the same system of equations, and do it. But now let's talk about it. So if we do 4x, like up here, we have 4x plus y equals 5, and we have 2x minus 3y equals 13. And we now substitute what we have. So it's 4, 2, because remember x is 2, plus negative 3. So negative 3, that would become a negative 3. We don't even need the plus anymore, the positive, equals 5. So this should work out if you were to work it out. So 4 times 2 is 8, negative 3 equals 5. And we know that that is correct now. And so if we take that 2x, which the x we know is 2, and we do negative 3 equals, okay, so equals, and up here it says 13, okay. So we know that 2 and 2 times 2, positive 2 and 2 is 4. And then a negative 3 and a negative 3 multiplied is actually now a positive 9, and that would be 13, and we have checked our work. So we know these are correct. So this is checking our work. We want to check our work, because if it doesn't come out, then we know that we've done something wrong within our steps. And sometimes Mrs. Spofford is even making simple mistakes right now, and so checking your work is always a good idea, especially if you have the time. I know that when you have a time test, you get a little bit anxious and you don't feel like you have the time to actually check your work, but it is beneficial if you check your work. Okay, so we're going to go on to a second problem. And the second problem I'm going to show you is the actual problem that was on your paper. So I'm going to write out the system. Remember, we're still using substitution. I am focused on substitution at this point. And we're going to take that system of equations that they gave you, and we're going to do those. Let me give you a second to get all my stuff together. So we have 3x negative y equals 2, and we have 2x positive 2y equals 3. And so this is our system. This is what we're solving. And so I want to take step 1. Remember, step 1 is finding which of these is going to be the easiest equation to figure out really quick. And of course, if you look at it, this negative 1, remember, pretend there's a 1 there, negative 1y, and solving would make it a lot easier. This is going to be the easier one to solve for. Okay, so we're going to solve for that one, all right? And so that's what I'm going to work on. And so we have 3x minus y equals, or excuse me, negative y equals 2. So we're going to take this positive 3x, and we're going to eliminate it from on this side and put it over on this side. We want to condense and regroup back over to the other side. So 3x and negative 3x. So it leaves us with negative y equals 2 negative 3x. Okay, now I don't like, and I say this with all due respect, I don't like at all this negative sign. It's bothering me. This negative sign bothers me. Now, sometimes you're going to have to use negative, but we're not going to be solving for a negative y when we go back over here. We're solving for just y. It should be y by itself and not a negative. So let's take that negative y and, again, take it down and break it down. Okay, so we could take it and say divide by a -1. So then over here I have to divide by a -1. And because this is multiplication, 1y, that's multiplication. Just like 3x, we know we're going to be multiplying right here. So we have to take it and divide. We have to do the opposite. So this would become y now by itself. But 2 divided by a -1 becomes a -2. But a -3x divided by a -1 becomes a +3x. So now I have my new equation. We want to put that positive in front of that negative, because just this looks nicer, it looks cleaner, it looks a little easier to manage. And so we just we flipped those factors around just a little bit to put it into an equation that's a little bit easier to look at. So now we're going to step 2. And remember, step 2 is where we're going to solve for actual x. Remember, we want to find x this time by substituting. Again, remember that word, substitute. By substitution, we want to take that second equation and substitute that y, because we have a new equation for y. We want to solve for x. So we're going to take 2x plus 2y equals 3. And we're going to substitute the y. 2x plus, or positive 2 multiplied at 3, positive 3x, -2 equals 3. So do you see how I just included this in that y's place? Now all we have is x's to solve for, which is so much easier. It just flows, and it helps you to understand and keep track of what you're doing. So the 2x stays the same, but we've got to solve this multiplication problem. We have a +2 and a +3x. Well, 2 times 3 is 6, so it's +6x. And then we have a +2 and multiplied by a -2, which would make it a -4, because 2 times 2 is 4, and that equals 3. Well, now we have a 2x, a +2x, and a +6x, which gives us a +8x. -4 equals 3. And so then we could take this number here, because they're both whole numbers with no x or y variable there. So we can say +4 on both sides, and we get 8x, because remember, this positive and negative cancel each other out, and then a 7 now. But now we got to get rid of this 8 in front of the x. And the 8 in front of the x, since this is multiplication, we have to do the opposite. That's division. So now we know that this is 8x divided by x, still leaves 1x. And then over here, it's 7/8. So we now know and solved for x. X is now 7/8. We know now if we went and put x and 7/8 up here, we would be substituting. That's why substitution. You're coming up with an easier equation to put into the other system of an equation, the other equation in the system, to come up with the answers x and y. So now we're going to take the x, and we're going to, in step 3, solve for y. So we're going to take our y equals, remember, we don't want to come back up here yet. We want to come over here and get our simple one, y equals, and then up there it says 3x -2. And so we're going to take that 7/8 and we're going to replace that x. So y equals 3/7 minus 2. Okay, so this is where it gets a little tricky, because kids often hesitate, or students often hesitate on these fractions, and fractions are just like division. So this is basically saying 7 divided by 8. Okay, and a whole number is just the fraction in question with the same number on top in the numerator and so this 2, if you think of it, this is 2 wholes. So that's 8 out of 8 and 8 out of 8. Do you see that? That's what this means. If you kind of take that whole, okay, if you take that whole, and you make them into 2 fractions, because 8 out of 8 is 1 whole and 8 out of 8 is another whole. So this would be 16 out of 8. And so now you have y equals 3 times 7/8 and negative 16/8. And so I hope I didn't lose you in that translation, but that's how I look at that whole number 2, that negative whole number 2, as 8/8 plus 8/8, because we're working with 8s. And so I'm just going to think that that's 8s that we're still working with. And so now I can figure this out. And this is a mixed fraction, but it's also multiplication. So it's asking us to do 3 times 7. That's 21/8. Because the 8s is still the same. We're still talking about 8s. We don't want to change that bottom, and we're still doing 8s. And then this is 16/8. And so if you do 21, take away 16, then you have 5/8. So y equals 5/8. And now we have both of our answers. We have y equals, and we solved for y equals 5/8 and x equals 7/8. And so if you were to go back up here and you were to if you were to put the 7/8 where the x's are, and you were to put 5/8 where the y is, then you should come out to the correct answers. So let's solve, or excuse me, check. Let's check our work. So I'm going to rewrite those 3 with a 7/8 in it. Negative 5/8 equals 2. Okay, so now I have this new system here. Okay, and it should work out correctly. Let me make sure I had it right. 3, and the x is 7/8, and the y is 5/8. Yes, so, okay, so we got it written out right. I just want to always make sure that I put the right place. So 3 times 7 is 21/8. Take away 5/8 equals, and so 21 take away 5 leaves you with 16/8. Well, if you do 16 divided by 8, doesn't that equal 2? So that one works out perfect. So see, 16 divided, remember fractions is like a division problem. 16 divided by that 8 is going to be 2. Okay, and so now let's try our second one. Let's 2x, which x is 7/8, and positive 2y, which y is 5/8, equals 3. And so now we're going to solve for this one. It's 2 times 7 is 21/8, plus 2 times 5 is 10/8. Okay. Let's just make sure I'm doing this. I'm sorry, I was thinking 3 still. This is not correct. Let me erase that. Please forgive me. It has been a crazy morning. Okay, so 14. 2 times 7 is 14/8, and 10/8. This is 24/8, which if you do 24 divided by 8, it's 3, so this one works out. And so this was our second substitution problem that we did. And so that's a system of equations. I'm going to do the last one as decimals. So I have shown you working with all whole numbers. So that is the easiest way to figure it out. That one's easiest. And now we've worked with fractions. And now I'm going to show you one with decimals. And decimals are just like fractions. They're just with, dots instead of a line.